Pick up where we left off, but I need some help. What were the products of this particular reaction? I think we got them down before the bell rang yesterday. Kira, what was one of my products of this single replacement reaction where we left off with our notes yesterday?
Like the full chart, balance.
Did we get? I don't even remember where we left off. Did we balance it?
I think we started with it.
Okay, go ahead and give me the balanced products then.
Okay, I had 2 HCl.
Good. Good.
Plus Cu salt.
Good. You got it. Nice job. So we've got our single replacement here. Single replacement, as you know, flash back to a couple days ago, involves oxidation reduction. This is just a little bit of a review, not about this particular problem, but just to review. Remember, K is solid, just single metal by itself there. It's going to have 0 for its oxidation number. Copper has a +2 charge. This is not related to net ionic. I just thought I would review this as we're kind of picking up where we left off. Chloride's -1. On the other side, potassium is now ion, so it's got a +1 charge. Chloride's -1 still. And then copper, if it's just solid copper by itself, what's the oxidation number of copper on the product side? 0. So then we can see the potassium changed its oxidation number. The copper changed its oxidation number. So that's why these single replacement reactions are part of oxidation reduction reactions here. Just again, a little bit of a review so we don't forget what we learned yesterday and previously. K goes from 0 to +1. So if its oxidation number increases, what did we decide that was? Do you remember, Joseph, if it goes from 0 to +1, is that oxidation or reduction? Yeah, good, it's oxidation. So we would say potassium is oxidized here. All right, and what would we say happens to copper if it goes from +2 to 0? Piper, what happens to copper in this reaction?
It is left out of the single replacement.
So look at its oxidation number. If copper's oxidation number decreases, would we say it's oxidized or reduced? It's actually reduced, okay? And again, I think of it because the number goes down, just like the water in the glass decreases, so the amount reduced. So if the oxidation number in any way decreases, we'll say it is reduced, or it gets reduced in that case. All right, so just a little bit of a review of oxidation reduction that's taking place here. Chloride, did anything change with chloride's oxidation number? No, so chloride didn't really participate in the reaction. That's something we're going to see when we get to this net ionic reaction stuff. Yeah?
Whenever we test on this, do we have to have the oxidation numbers memorized, or will we get a sheet?
You'll have to, you'll need to know those. You'll need to know those rules that we went over. I figured out the oxidation number of. You need to definitely know that single elements by themselves are 0. Pure elements are 0. And then you'll need to know, like, group 17 is usually -1, right? But that's something you already kind of knew. You know how to find the charges on the periodic table. And I use that to figure out copper. So, like, knowing that copper is +2 is something you'll have to be able to figure out by looking at what it's bonded to. But those rules are something, you should memorize or learn those rules, like the things about oxygen being -2 unless it's a peroxide. You'll need to know that. Hydrogen is always +1 unless it's bonded to a metal, then it's -1. Those little exceptions about oxygen and hydrogen, you'll want to know those. Those won't be given to you. That's a good question. All right, so we see its oxidation reduction. Adam has a question.
For the balanced equation, does the K on the left side need 2 as well?
Thank you. It does. Thank you. Yep, sure does. Big 2 there for the balanced equation. Thank you, Adam. All right, so that's where we left off. I'm going to erase my oxidation numbers now. We saw that it's oxidation reduction, and it actually kind of is important that going through that, we saw that nothing really happens to chloride. And so it turns out chloride is going to be a spectator once we do these next steps on the net ionic reaction stuff. All right, let's get a full ionic equation underneath this and break up the things that are aqueous. So first of all, on the left-hand side, is K aqueous? No, it's solid, right? So you just repeat it just the way it is. So for my complete ionic equation, I'm just going to put K solid. All right, then I see CuCl2 is aqueous. So let's try to break that up into ions. Broadfoot, what's one of the things that CuCl2 will break up into when it dissolves? Cu. What's the charge of Cu here?
0.657.
No, it's part of this compound though. So this is going to be 2 plus because it came from that compound, and it's not exactly by itself. It's the aqueous ion here. If it had an S after it for a solid piece of copper that you could visualize as a piece of copper, then it would be 0 by itself. But if it's aqueous, it's in ion form. All right, what's my other ion going to be that comes from this? Vivi? 2Cl, very good. 2Cl, does Cl have a charge? Vivi, what's the charge of chloride ion? -1, so we want to put that on there. All right, then we come over to the other side. All right, now we're going to distribute that big 2 in front of it again, just like we did on the one on the bell ringer. So that 2 applies to both of these guys here. So what's one of my things that I'm going to get when KCl dissociates? What's one of the ions going to be? Maddie Smith?
2K.
Good job, 2K. Does K have a charge?
Yeah.
Yep, it's part of the compound, so it's K plus. All right, what about chloride? Ainsley, what am I going to do with the Cl part here? Good job. And minus, great. Minus AQ. All right, and then copper is solid. So, Jonathan, what am I going to put under copper solid? Same thing, exactly. Just drop it down exactly like it appears if it's a solid. This is our complete ionic reaction. It's a little bit shorter this time for the single replacement reactions. Compared to the last one we did, I can fit it on the screen. Does anything cancel? Claire, what's something that might cancel here? Chlorides, you got it, 2 chlorides. The other things do not cancel. And sometimes people are like, well, it's still K. But look, it's K solid on the left, but it's K plus aqueous on the right. So that's all that actually cancels here. And then we're left with our net ionic reaction. 2K solid, 2 potassium solid, plus Cu 2 plus aqueous. And it yields 2K plus ions plus Cu solid. So this is where I really think I can really see the power of a net ionic reaction. I can really see what's going on in terms of the oxidation reduction reaction when I look at the net ionic reaction, because you get rid of all those things that weren't really involved in the reaction, like the chloride. You got rid of the spectators. It just helps us focus on what's really taking place when the reaction occurs. And we can see the charge is changing on those ions and atoms because electrons were being transferred in the oxidation reduction reaction. Since this was a single replacement reaction, I just wanted to do a demo of one, especially because we had some copper chloride out. That's what we just poured most of it down the drain. But this was the unknown copper chloride that you did in the lab. It's the same copper chloride as in the reaction here. So this was the unknown, and I've just got a little baby test tube here that I'm going to pour just a little bit of it in. And I don't have any potassium metal, but I do have magnesium, which is also above copper on that activity series. So just to kind of see a single replacement reaction taking place and why I emphasize that it's a solid on one side and then copper chloride is aqueous and it changes. So we can definitely know that copper 2 chloride is aqueous here because you made it yourself. It's a solution. And then this is my solid piece of metal. This is really magnesium, but it might as well just be potassium. Magnesium though is really nice because it's really flexible and bendable, kind of like aluminum foil here. So it's a solid. So in this reaction, this potassium would be a solid piece of metal at first, at the beginning of the reaction, just like this piece of magnesium is. And then I'm going to just place it in here, and it's going to take a little bit of time. I need to kind of stuff it down in there a little bit. But over time, over the course of the class, it's going to change. Right now, it's kind of a shiny metal. It's kind of silvery on the outside, but it's already starting to kind of darken a little bit. I'll use a stirring rod and stuff it down in there a little bit deeper. So we'll look at it at the end of class to see if any other changes have occurred from that shiny piece of magnesium to what happens to it eventually. My fingers are covering it with stuff. It's kind of float. All right, so let's keep an eye on this for the rest of the class period to see what changes. I'm going to use something in your laboratory here to stuff this down a little bit deeper. Bubbles attached to it that just wants to float. Okay. Mentioned by the end of the class period, we'll see some solid copper. So the copper was dissolved in the solution. It's the kind of blue-green substance in the solution. But the solid copper is going to form on that piece of metal. And so that's where our solid copper comes out on the other side. When as that happens, the potassium, really in this case it was magnesium, is dissolving into the solution. And so the potassium becomes dissolved in the solution while the copper metal is actually starting to form on the outside of this. You can already see those little specks of dark kind of brown in there. Those are specks of copper that are already starting to form as solid pieces of copper. All right, so we'll take a look at it as you're working on your net assignments for the remaining part of class. So I'm going to pass this out. This is actually the homework for today, but I want you to have some time to practice these. I've divided these up into parts, kind of the different reaction types. The first page are, the first page, you start off with 2 double replacement, and then I've got a single replacement down here on the bottom of the first page. So it's going to give you the molecular equation, balance it, break it up into the total ionic equation, where you actually will show every single ion. Those are the ones that you have to write small. Like in red there, it's got all the ions, and then the net ionic equation is what's left, like in purple here, after you mark out the spectators. Then on the next page, there's again some more of these where you might think about what are the spectators, or think about what the products are that form with those. And then I wanted to include some acid-base. So acid-base net ionics are on the last page here, and then there's some single replacement ones that you'll also practice here. Let's get this one curled up. I think over the weekend they sanitized my classroom, and so all the top papers spray, they all like curled up and bent up. Couldn't figure out what happened over the weekend. Sanitizing spray.
Good spray.
They use this like, has anybody had to leave your classroom when the big Ghostbuster thing comes in there? Yeah, so they've got this big sprayer thing, and it looks like something from Ghostbusters. So they'll spray down your classroom, goes on Mondays now too, is the other thing they use that for, and it's supposed to be like ultra sanitizing, but you can't be in the room when they do it. So that's why if your class has to go to the auditorium in the middle of the period, it's because they're coming in there and spraying. All right, so again, we're starting with the double replacement, so you might want to go to the example double replacement one that we did earlier. Break up your ions, but if it's solid, you keep it together.